Hello, all, and welcome to the June Tech Talk with Bram. Today is going to be a special treat because it's not one of our regularly scheduled programs, but we just get to dive into the mind that is Bram. He is well known for BitTorrent, well known for Chia, and also well known for a lot of his mechanical puzzles, which he and I have been talking a little bit about before this meeting. I know we have a few questions held over from the event with BW Free that we're going to go ahead and start off with. But I just wanted to give a shout out to our Discord server. If you have any questions for Bram, feel free to join this Zoom webinar and ask in the Q&A section, or jump into our Discord server and ask inside of the community feedback channel. I'm going to turn a lot of this over to Bram so we can explore his insights into technology, puzzles, Chia, blockchain, and everything else kind of under the sun. But feel free to ask your questions as we make it through the rest of the event here. Now, Bram, one of the first questions that we have, which is a holdover from last week's event, is more general about blockchains and
Hmm.
math. And
Yeah.
what are some of the new technologies or new enhancements that you've seen across blockchain development or math that really excites you?
Um, well, gee. There's a lot less technology in a lot of blockchains than people think. Um, that said, the stuff that's always, ongoing is zero knowledge stuff. There's always stuff being done there. And in particular, now people are trying to go crazy applying that to enabling side chains, um, which which works. It gets into this problem that sounds like one stupid little problem, w- stupid, ugly little problem, which is you need proof of publication when you have a sidechain, because otherwise it could just get bricked because nobody knows what the state of it is and they can't update it because there's a Merkle root that was published that is a valid Merkle root, but since you don't know what it goes to, you can't do anything with it. Um, that's um, uh, That sounds like a stupid, ugly little problem, but stopping double spending sounds like a stupid, ugly little problem. But there's stuff going on in there that's kind of interesting that Eigenlayer is doing. I have trouble getting excited about working through what they're doing with that because the problem is just so annoying. But there's definitely zero knowledge stuff that's necessary to enable all those things. That stuff is way less applicable to Chia than you would think because the extra cost of actually doing a reveal of everything that you're doing isn't nearly as bad on Chia as it is on other things. The relative amount of the cost that's going towards actually updating the state is a little larger and more direct in Chia in general. Um, but there's always fun stuff there. And of course, it wasn't that long ago that all zero knowledge things were just completely science fictional. Um, the world of things somewhat directly relevant to Chia. There's a recent results about how to do hashing to a point in a class group and doing that efficiently. Um, which I've not looked into at all. Just intellectual triage. There's only so many things I can hold in my brain at once. Um, by the way, I'm at the very tail end of a cold now, so my voice is kind of shot. So sorry about that. Um, but we might use that in the future. It's not that ridiculously compelling. It's like it would be a hard fork, and it might allow for blockchain validation to be much, much faster. Because if you used the same curve for a whole section of things, you could use a single proof of validity for a single witness to a whole section of history. So that would allow weight verification to be much, much simpler. But that's not looking like something we're super moving on at the moment. Of course, right now, something we're actively working on is our proofs of space, um, which is a lot more on the attack side than on the defense side. So, um, uh, so, uh, so Max and Nick explained to me what the hell is going on with the attacks that we, Chia, the company, hadn't figured out. Um, and we're working on our next generation of it, which at the moment mostly consists of Harold building out a new prototype and Nick doing a pretty extensive analysis of here is all the attacks that seem relevant, and here's how well they work when the knobs are twiddled in these various ways. Um, the amount of the amount of knobs that we've added really isn't all that much. The amount of modification to the proof of space format that we'll have in the new one is actually kind of tiny. There's um, we're like increasing the number of tables and might kind of do a double lookup, maybe not sure about that. The main thing is that um the way things are hashed together, there's this cute construction I came up with that basically makes it so computational work is added at each table instead of all being kind of front loaded at the beginning. It turns out our matching function kind of saved us, which was really funny because we didn't think of the matching function as being a security feature in that way. It's a security feature for other reasons, but um, because because in practice the matching function is really the thing providing the a lot of the practical security that's actually happening in our old proof of space algorithm. Uh, I very intentionally designed something based off of that. That's a lot cleaner. That it's a lot more coherent about what the thought is that's meant to be a security feature in the new one. And it's looking like this is going to go really, really well. That like the new proof of space is going to be very resistant to time space trade-offs. And it's doing it without being gimmicky. It's not like adding, oh, well, we know about this thing, so we added this gizmo, and we know about that thing, so we had that gizmo. It's like the actual underlying algorithm is just being switched to something that's much more confidence inspiring and is, if anything, simpler than the old one. So that's a bunch of stuff going on there. Obviously, I'm working uh, on my gaming stuff right now. So that's um that has some technical meat to it, but not a lot actually. It's all super subtle, but it's not hard. It's all like it's all stuff you can just sit down and explain to someone. It really doesn't get into a lot of deep math. It's just asynchronous thinking, which throws people pretty badly actually. But yeah.
Yeah, a lot of exciting stuff for sure, and
Hmm.
appreciate you going from new stuff and other ecosystems and tying it back into Chia for us as well.
Uh-huh.
And on that Chia side, I know that there is a new version of Chialisp that's been in development for a while. Do we have any new updates on that, or do you mind just doing a quick overview as to
Well,
the reason for it?
there's Chialisp 23. So ongoing, the numbering scheme of each thing is that it's the year that it came out, right? So um the um so Chialisp 23 is now baked and Chialisp 24 is in development. The plan is that you get a sigil in your you have a sigil that identifies the Chialisp version in your Chialisp file. So even as Chialisp gets upgraded, the exact set of CLVM, the exact data structure that this individual file compiles into will never be changed because the optimizations for old versions never change. So you get new optimizations in new versions, um, but they're not uh, but they don't change old ones. That way you can always reconstruct all your old stuff because in Chialisp, being byte identical is very important for doing stuff. There's a lot. If you compare, I think the one before it might have been CL21 actually. Chialisp 23 actually acts a lot more like a real language. Well, it's in terms of stuff that's new, and there's really, really basic stuff. Like if you typo a variable name, it gets mad at you instead of doing something truly bizarre. Um, so that's super important. Everybody really wanted that. There's a bunch of stuff about macros that I don't understand, but there's new style macros that are better. There's well, all this stuff about like capturing stuff in assigns and things like that that make just normal programming easier to do. And then you can things can be like recursively defined and call themselves and stuff. Um, and then you also can like your dependencies work. It doesn't need a separate build system. So if you have like if you have like a program that's used by multiple other programs, you put it into the head of it into a CLSP file, and then things can import from that, and they are guaranteed to get the exact same byte for byte view of what it is that they're pulling in when they're all pulling it in. So if there's something that needs for interoperability purposes to all SHA-tree to the same value, you pull it in that way, and it is at that point guaranteed to be fully baked and consistently give you the same thing as you're pulling out of it. The general setup there is that the boundaries are on CLSP files. So a CL Inc file is just like a file. It's a bunch of Chialisp code that's a higher level language, and whenever you pull things in from another CL Inc file, you're going to share a function table with them, and reused functions are going to be deduped that way. And you can get optimization across these things. If you're pulling in from a CLSP file, that's a boundary. So that thing that you're pulling in is not going to use um, the same function table as you are. That's really super important when you're doing just normal Chialisp development and you're going to be interoperating with other smart coins and stuff and actually need their hashes. So it's really painful to not have that. So following in kind of the same sort of philosophy as you have in like in Python for these things, you don't need a separate build system. You just write your code and run it and import does what you want it to. So yeah, so we're head of C++ plus plus on that one. Yeah, so those are kind of the big things in it to my mind. I tend to forget everything that's missing from the old stuff, but yeah, over the course of 2023, Art really, really added a lot of stuff to the language, and so I'm not remembering all of it off the top of my head. Um, but yeah.
No, understandable, and thank you for the detailed overview as well. And for those interested in seeing how this applies to different puzzles being created, I know one of the puzzles out there using it, developed by a community group, is by Circuit DAO, and their circuit tail is developed utilizing Chialisp 23. So a good thing to take a look at and see how that can flow within the puzzles themselves.
Mhm.
Now, Bram, there's a question about one of the community projects that was recently built out, and there's some inkling or relation to kind of BitTorrent and the concept of file sharing in a distributed way.
Oh man.
That project is Splash, and it's created by the team at Dexy, which is a peer-to-peer offer file trading system from Dexy.
Uh-huh.
Have you dug into Splash? Do you have any
I
insights or
I don't
thoughts about it?
know I don't know anything about it at all, so I can't
Okay.
really.
Yeah,
Yeah.
no worries at all. No worries at all. Yeah, definitely an interesting one to take a look at there. And I know that they're just getting it up and running, but it's going to be a great system for sharing those offer files in a decentralized method for us.
Hmm.
Now, to touch on something outside of the technical realm of Chia and blockchain, we have a more general question by Steve Stepp, and it
Hmm.
is, what is your favorite movie that has computers or technology involved in it?
Oh man. Movies tend to do a really, really bad job of having technology in them. It, it's it's sort of forgivable when you have a if you're doing anything science fictional or fantasy, there's just a premise, right? And so you just make up what the thing does. So you just conveniently make it up. Um, and that doesn't have to be real. It's not claiming to be real, right? Um, the what I find really offensive in a lot of screenwriting is when a character is supposed to be very, very smart, because screenwriters themselves are not generally speaking the sharpest knives in the drawer. Um, and they don't know how to write smart characters. And if you like say that a character is a great like musician or illustrator or things like that, then then as a screenwriter, you just say, "Oh, well, they are," and you just say, "Here, look, there's a painting that shows up here." And you know, when you're making a movie, an actual painter does the actual painting. Um, but as a screenwriter, if you claim that a character is very, very smart, you're writing their dialogue. and, and so you get these supposedly smart characters who are just kind of these know-it-alls whose only noticeable smart trait is that they know a lot of trivia because they're using the answer key because they don't have to look up anything because the the screenwriter's doing it for them. Um, and yeah, so the depiction of smart people in general is kind of dumb as a result of that. I've been trying the last whatever number of years to follow movies just to get like cultural references from it. It's really kind of sad. Like the cultural relevance of movies in general has really, really uh, 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 died down. Um, and I mean, this is a big cultural shift that like when I was a kid, the never-ending context of American culture was rock and roll dominated music, and the highest kind of social status you could have was being a movie star. And that seemed like this just internal state of things. And now rock and roll is dead. And um and now instead of influencers wanting to be movie stars want to be influencers. So that's um kind of took the just took the being a tabloid character and boiled it down to its essence. But as a result of that, movies have really lost a lot of their cultural cachet. And they've also lost a lot of their cultural relevance. And it's like people don't make comedies anymore, and there's like no meaningful social commentary in anything these days. Um, so yeah, I mean, really hard pressed to name like a science focused or science fiction movie over the last few years that actually kind of really even had a pretense of actually talking about real science in it. It's like just it's just like another fantasy universe, really.
And here I thought you were going to say war games.
Um, are we connected?
Yes, I'm hearing you come through loud and clear.
Oh, yeah.
Good old technology.
Yeah, you've been breaking up pretty badly here.
Oh,
I
well,
don't
I
know if it's
will
on my end or yours.
take a look at that. And in the meantime, I do have another off the blockchain and Chia topic and on to more of the puzzle side of things. And Steve is asking, just for fun, does Bram use cross to solve a Rubik's Cube or some other method? Essentially, how do you go about solving a Rubik's Cube?
Oh, well, there's a few answers to that. So there's the solution that I figured out when I was 12 years old, which I posted in its entirety on my blog a little while ago, which had been on my to-do list for like 30 years. Um, and I don't do that one all that frequently because it's slow. And I kind of feel now that I've gotten it out there for the world, I cannot worry about it so much. That one's interesting because it doesn't use commutators, which is very unusual for Rubik's Cube solutions. Um, the and actually, on the scale of Rubik's Cube solutions that don't use commutators, that's a pretty fast one. If I'm just solving it, um, I use kind of a beginner method that I do a cross and then three of the bottom corners, and then three of the middle layer edges using the missing corner as a keyhole. And then I do the final corner on the bottom layer. And then I use a second layer algorithm exactly once for getting that remaining edge. And then for the top, I do I orient the um I orient the top edges and then I orient the top corners and then I position the top edges and then I position the top corners. So kind of sort of a dumbed down Friedrich method that's sort of beginner friendly. Um, this is not particularly fast. I take forever to spot anything when I'm solving, so I'm not a fast solver in the slightest. But this is a reasonably fast algorithm that's reasonably understandable. I mean, not just reasonably, it's totally understandable. So yeah, that's the approach that I take for the for the orienting the top edges. I do front, up, right, front. Uh, and for orienting the top corners, I do soon. I think it's soon. Um, I'm not a speed solver, so I don't have all the names of everything memorized. And then top edges, I do kind of using the normal one of the normal things for it. And then top corners, I position just by keyholing, doing like a front and then the front, down, front, basically, and then I use that to keyhole the up, front, left um, position. Uh, yeah, that's the that's how I solve a Rubik's cube.
Gotcha. Thank you. Thank you. I went ahead and dropped off video to try to help with the bandwidth issue
Uh-huh.
here, just because I'm also live streaming as well. So if you saw it change, that was the reason there.
Yeah, I think you're doing better now. So
Perfect. Thank you. Thank you. Another question we have, we're going a little bit more back to the blockchain side, and this is a follow-up question from our event last week. For those who did not catch our event last week, where we had BW Free interviewing Bram, that is available on YouTube, so do check that out. One of the follow-up questions, though, you had a conversation about trailing emissions and how trailing
uh-huh.
emissions are bad. Do you mind going into a little bit more
Well,
about why trailing
well,
emissions are bad
well,
and how it might affect?
not having trailing
Or,
emissions is bad.
I'm sorry, yes,
Um,
yes. Not having
yeah.
trailing emissions is bad. And how do you see
Oh,
that problem playing out for Bitcoin?
I don't know what's going to happen with Bitcoin. So if you get if you get down to the point where the only rewards happening are from transaction fees, um, then what tends to happen is you get these overnight cycles that you have fees during the day and then zero at night, right? If you're lucky, it's kind of even all the time and it doesn't really matter all that much. But the nightmare scenario is you get these periods of nothing. And during those periods of nothing, it's really not worth it for people to do mining because the difficulty is the same as it always was. Um, so what you expect to happen is that for the most part, everyone just turns off their equipment. So you get like blocks being made during the day and then no blocks being made at night. But then some people are going to find it worthwhile to make blocks for longer. And then overnight, you do have this potential for making money where overnight, when everyone else has turned their stuff off and the blockchain is basically stopped, you can spend some time reorging the very end of what happened during the day. And then this can start feeding on itself. Then people start turning their stuff off earlier because why should they run it when it's going to get reorged? And then you start reorging more and more over it. And then it just and the window of how long the blockchain is actually running starts shrinking down to nothing every single day. So this is horrible and not something you want to have happen. Um, Ideally, what you want to do is kind of like something they did in Ethereum, which is theoretically good, but in practice, not so much because, of course, making it so that you have constant fees all the time means you have constant fees all the time. So you can't just wait to let your stuff go through overnight and get through cheap if you're not in a big rush. So it makes the markets really weird because it assumes that everyone has the same sensitivity to latency, which is not the case. But um, when you're what may happen in Bitcoin, either there happens to be consistent fees all the time, in which case it's not a problem, which seems quite unlikely, or the whole thing just becomes a disaster, which is entirely possible, or Bitcoin does basically adds in trailing emissions, either by literally adding in trailing emissions or with a hard fork, which would be very much against what Bitcoin wants to do in general, but or by doing something to spread out transaction fees. The problem with trying to spread out transaction fees is that people can start getting paid under the table for including things in blocks. So instead of putting a formal transaction fee in your transaction, you kind of, pay a given miner to put their thing in, and now you're not having to pay into the general transaction fee thing. You're paying a fee directly to them. Um, so in Ethereum, people haven't done this because Ethereum is so centralized, it doesn't matter. There's only like you can't really pay under the table because there's not enough miners to pay under the table too, which is not really a good thing. But in Bitcoin, it's decentralized, so that would be an actual issue there. So it's a little hard to say what's going to happen long run. It does get kind of scary eventually over the course of the coming decades. Is over the next like 10 happenings, it gets gnarly.
Absolutely, absolutely. And it's great to have that insight into how things might occur in the future. And it's obviously well designed inside of Chia to help negate a lot of those issues.
Well, we just left in trailing emissions. Not it's not complicated. Like we did a few happenings just to so that there's more getting out there and getting some liquidity going on early, and then later on you just have trailing emissions.
Absolutely, absolutely. And on the Chialisp puzzle side, we have a great question from Sebastian Trepka, and it's
Uh-huh.
how should one generally approach auditing puzzles in smart coins?
That is an interesting question. Um, uh, I like saying that formal verification is the morning after pill of debugging. um, that um, the generally speaking, the as a matter of practice, if we look at issues that have come up in the past, um, most of them have been from one stupid thing, which has to do with messages going between coins. And that issue is largely fixed if you use um, uh, that issue is largely fixed if you use messages instead of announcements. So messages are coming soon. These are message conditions at the conditions layer. Um, so I would say first off, you should be using those wherever applicable. Those are much, much better to use than announcements. Because usually with announcements, you're kind of reconstructing messages badly. So it's better to use the built-in thing that really, really does it right. Um, and that's of the three serious things we've encountered in the wild. I think all three were caused by issues related to that. So that's by far the number one thing is be leery of announcements and use messages instead. Um, Side of that, I'm not really sure. Chialisp tends to produce solid code just in general by its nature. It's kind of designed trying to do that. Um, we've had people audit things. Um, it's it usually doesn't turn up much. So it's a little hard to say how best to go about auditing things because it's like usually most of the time when you write stuff in Chialisp, if you go about the exercise of auditing it, you don't really find anything. Um, as long as you kind of stay within what the coin set model is trying to make you do and just embrace it and accept it. Um, your stuff tends to be pretty solid that way. Yeah, if you just want to go through the exercise of claiming to have done an audit, you can pay people and stuff. But if your primary concern is mostly, I'm actually worried about, security problems in my code. How do I avoid them? It's a little hard to differentiate that from just normal good programming practice, the way Chialisp is set up. But like by far, the number one by far thing to do is try to avoid announcements and use messages instead. Announcements should be restricted to like Oracle reporting, not actual coordination between smart coins.
Thank you. Thank you. And on this point, obviously, we just dove pretty deep into puzzles themselves, so I want to go a little
Mhm.
bit higher level. What are your suggestions for developers who want to start learning Chialisp, and what skills are most relevant? And thank you, Orc, for the question.
Gee, I've been off on my own little island working on like improving the thing as a whole, not so much documenting it. So on chialisp.com we have documentation about things. I think one goal that I have, aside from it just being usable, but one goal I have for the gaming stuff I'm working on now is for it to be that if people want to know how to do stuff in Chialisp, they can go look at the gaming code and get some idea of what are some pretty good practices to use here. Um, and so, like right now, you can go and read like how like the code for doing cats, which will tell you something, but that's pretty archaic at this point. That's like we know better ways of doing these things now. That's using a really, really old version of Chialisp. So usually what you want to be doing is going and looking at extant code for it. And I'm not sure what currently today are the best chunks of code to go look at to see how to do things. But I am hoping once I get it working that the gaming code will be really, really good for explaining how to do stuff. It will definitely show you how to use like state channels, which is not being done right now.
Thank you. Thank you. And Orc had another side question on that as well, and
Mhm.
specifically more on gaming. How are
Yeah.
you approaching gaming, and can you describe a little bit more about those state channels, how people are getting into the actual channels, and what's occurring?
Oh, yeah. So these are very much like Lightning state channels. Uh, a state channel is when it's between two people, there's a few variants, but the most basic thing is you have a coin that looks like a normal coin on chain that's a two of two spend, like at the signature layer. So so there's this coin that's on chain that if you and I both sign off on what it should go into, it gets spent to that thing. Um, so what we want to do for a the backstory is we were talking about setting up a payment channel network, and I'd done a lot of thinking about that. Um, and we're talking about how to approach doing this. And the people who actually work on Lightning were like, you don't want to build Lightning. It's horrible. It's horrible for a reason that's stupid, which is that you need like people to pony up real money and have real world business relationships to get liquidity and routing in the system. And that's not a technology problem. And so I was like, okay, cool. I'm going to build gaming. So to avoid having a network, the idea is that every time you want to do a like poker session with someone or well, gaming session in general, you can mix and match games over a channel. You have one transaction at the beginning to set up the channel, and then you know go about using the channel, and then there's usually, if everything goes smoothly, exactly one transaction at the end of the thing to shut the channel down. That the channel coin gets spent to what you want to get spent to. So that avoids having to worry about routing and stuff. It means that you need to wait a minute for your thing to get set up at the beginning of a session, but that's not a big deal. And we can add routing to make that happen in the future, but that's comes with headaches. So, um, yeah. So for um, so the right. So the question was, what's up with state channel? So a state channel has virtual coins, right? That this channel will get spent to, excuse me, got a cough. This channel will get spent to create some coins in the future. But they're virtual, right? So what we want to do is net out in the end. So we want to be doing this thing where we're playing a game where we're spending coins, but we're spending virtual coins. So all the intervening spends don't actually have to happen on chain, meaning we don't have the transaction costs for them and don't have the latency of doing them, and we just kind of jump to the end state of the whole thing. So the idea here is that we are updating the virtual coins in this channel. And then at the end, the virtual coins become real. Either of us can force the current state of the virtual coins to get unrolled and exist on chain, and then we can finish up playing whatever hands were pending at that time actually on chain. And so kind of multiple layers of optimization here that first off, you try and do everything inside of a state channel. And then on top of that, the actual way games are played is the game coins run something called a referee, which optimistically accepts the moves of the two sides. You simply declare, here's the new state of the thing. Because that's much, much cheaper than having it run through game validation on every single turn. And then if somebody tries to cheat, then the other side says, no, you cheated, and demonstrates it and slashes the other one. And that's the one and only time that the actual game logic is ever invoked. So trying to avoid that as much as possible for cost reasons. And then on top of that, the games being used are ones that are suitable for the medium that have very, very few turns in them because turns are slow and expensive. So that's the general approach that we're taking here. Poker is a pretty good fit because poker is already a game. It's designed to be played under similar circumstances. Poker is a game designed to be played between assholes who don't trust each other. It has a lot of the same properties. Um, it does have some things that turn out to be a little bit skeuomorphic, most notably being that it has a permutation of cards, which is actually very hard to do in the medium here. So the poker variant that I'm doing, you're basically playing with an infinite deck, because that's way easier. I think that more than answered the question at hand.
Absolutely. Yeah,
Yeah.
thank you very much. Thank you.
Uh,
And as always, I appreciate you diving into all the sides of these
mhm,
conversations, and that's why
mhm,
we're having these tech talks with you, is we love picking your
uh,
brain and getting more of
uh,
that information out there.
uh,
And looking a little bit more on the puzzles themselves for the games, as you
yeah.
identified, there are some limitations, like with poker, it made it a lot easier to do an infinite deck. What are some
Yeah.
other considerations like that when you were building the puzzles themselves?
Um, so they have to be turn-based, and two players. Getting into like two players is easy. You basically do I cut, you choose. I'm not familiar with the literature on multi-party channels. I suspect they get really unworkable really fast. A analogous, if not directly applicable problem is the one of like I cut, you choose for like a cake. And if with two people, it's really simple. If you want both people to be able to know for sure that they're getting a fair portion of a piece of cake, one of them cuts it and the other player picks one of the two sides. So that's a very simple protocol. And then there's this seemingly innocuous question of, okay, how do you generalize this to more players? Um, and this gets really complicated because now every single individual player needs to be assured that they are defended against a cabal of all the other players conspiring against them. And the number of cuts, I think for like five players, you're talking like a trillion to the trillion of power and shit for like the optimized protocols people know. It's just not happening. So I'm not even going there with multi-party stuff. Like maybe you could pull it off for three, but that's super dodgy. And then of course there's collusion within the game itself, within the game rules, not just at the channel layer at that point. So I don't trust anything more than two players at all. So it's two players doing games natively for money, obviously, because that's sort of the whole point. Um, and very, very few turns, and completely turn-based. So those are your basic criteria. Yeah, and then right, and then there's collaborative randomness. So basic collaborative randomness that's completely independent is easy to do using commit and reveal. But making it have extra properties like being a permutation, that's highly problematic. So I think that pretty much covers all the criteria that I've noticed for one. But that cuts it down a lot. Like you need like you getting pretty specific about the kind of games you're talking about here. Oh, and also games that are like legitimate games of skill that aren't just gambling, that have at least a decent amount of skill in them. Maybe not things that you could have like a world championships in, but definitely things where a good player will easily beat a not good player in it.
Thank you. Thank you. And yeah, definitely a lot of great insights there. I want to touch a little bit more on some of the other Chia development. And we've talked a lot about state channels itself,
Mhm.
which some might say is a form of L2 in its own, but
Most definitely.
yeah, more on that L2 concept. Do you see obviously state channels are going to be coming out first from CNI?
Oh,
What other ways do
definitely.
you
Yeah.
see L2s evolving on Chia?
We're not pushing it right now. There's a lot of overselling going on of L2s now because it's really just a side chain. And so often people are like, hey, we have a scaling problem. I know, let's make an L2. And that's like, okay, well, you have the same scaling problem you had before now. Now it's just less secure. You're just outsourcing it all to some, in practice, just kind of trusted party that's basically keeping track of the L2 with like a lot of layers of crap on top of it doing this stuff. So um, in principle, you can build these things on Chia because we have BLS opcodes and you can build zero knowledge stuff using those. Um, but we're really not doing that, or just from a like a priority standpoint, that's way down our list of things to do. We're working on really, really basic things. We're working on improved custody, really, improved custody arrangements, right? So we're dog fooding a custody solution that we built for ourselves, and we want to iterate on it. I put together notes on that the other day. We're going to be working on that. We're working on just distributed markets. We're working on just very, very basic um, meat and potatoes kind of features before we get into craziness, especially craziness where it's like, hey, let's fix scaling, which is always the ridiculous thing. That's like, let's have more scaling. And Ethereum was like, oh, well, we're the world's computer. We're going to have infinite on-chain scaling. And that was just stupid. And now they just conveniently pretend like they never made such claims, which is outrageous because that was their whole shtick a couple of years ago. Um, uh, so yeah, one of these putting thoughts into it, but maybe later kind of situations.
Absolutely, absolutely. No, I think you hit the nail on the head there too. And state channels are going to be a great L2 for Chia, and the additional scaling can come in the future because the opcodes are already there.
Yeah, well, you always want state channels to be kind of the backbone of layer two stuff that you're doing in general. You can they improve everything so much that it's like yeah, instead of having like just the big machine gun thing, you should do the more basic solution.
Absolutely, absolutely. And going a little bit back to gaming here,
Mhm.
there's a little confusion as to how the coins are interacting and what funds you'll actually be using within these initial set of
Oh
games.
yeah, yeah. So there's so you make a connection to some peer, right? And one of you makes an offer. Say, you discuss the balances, that how much you're going to put in, and so then when you've got that settled, one of you makes an offer saying, "Here, I wish to play a session with you, and here's the amount that I'm putting in, and here's the amount that you're putting in." And they send this offer file to the other side, and the other side finishes that out, accepts the offer, and introduces it to the chain. And this now creates the channel coin on chain, so which was partially funded by both ends. And that's how it's bootstrapped. That then just sits there. It's not doing anything. And the coin is a two of two coin, so the two sides are kind of doing partial signatures of various unrolls that could happen that they're sending to each other. And eventually, one of those gets finished out and something actually hits the chain. That's the high level of it without getting too much in the weeds of how they work. I guess I can explain that. there's various approaches to state channels that have been discussed. I'm doing something that's a little sophisticated, but also kind of dumb. I'm doing the dumb version of the sophisticated approach. So, the really simple thing, which is the original Lightning approach on Bitcoin, is to use slashing on the channel coin. So if somebody tries to introduce an old version of the state, then they get slashed and lose everything. That's kind of extreme and kind of has all these other attack modes where you trick the other person into trying to unroll an old version and slash them over it. And just it's nasty and seems unnecessary. So I'm doing something that's a little more similar to L2 ELTOO that Lightning has proposed, but dumbed down. So the rules are that whenever you start an unroll, that the coin that you go into says, well, I can be superseded by a more recent state than this, but it has to be the other side that did it. So each state has a sequence number on it, and one's initiated by one side are even, one's initiated by the other side are odd. So the state channel coin, when it unrolls, goes into an unroll coin. And that says, well, after this amount of time, I will make these virtual coins are going to become real. Here's the conditions I'm going to spend. And if and short of that, what can happen is if there's a newer sequence number that's after this value that created me, and it's of the opposite parity of this one, then I will unroll to that immediately. I will just make those conditions right away. Um, and the timeout doesn't happen. So that's the basic technical meat of it. That's actually kind of the simplest part of the entire thing.
Yeah, thank you. And as you say, there's so much other stuff outside of it that has to go into play for these things to be functional on
Yeah, the
chain.
logic to handle a state channel is actually really complicated and subtle because it's all so asynchronous and has so much like failover happening everywhere. It's really surprisingly hard to write. So that's what we're in the middle of right now. That I wrote a spec for that, and then me and Art kind of pair programmed it together, and now Art's debugging it while I have conversations with him explaining what all this code does.
Absolutely. Yeah, thank you very much. And very excited to see this hit the chain as well. I know a lot of people were excited to see the community built rock, paper, scissors game come out, which is another on-chain puzzle,
Mhm.
and definitely intrigued to see what CNI has to offer once state channels are available.
Yeah, that one's a little neat. That it kind of shows that I'm kind of jumping way ahead on this. That I'm not like there's an approach you could take where you say, well, first we're going to demonstrate this thing, and then we're going to demonstrate that thing, and gradually get more sophisticated. And I'm not doing that. I'm just jumping straight to the like actual thing that you actually want. Because the things leading up to that, while they're neat, are not really very practical. So um, yeah, that's why this has taken me a while, is because I'm really kind of building the whole hog all at once.
Absolutely. Absolutely. And definitely a great approach to it as well, because it gets all of the info out there. And like you say, the state channels themselves are going to be highly innovative.
Mhm.
Um, Specifically on what types of assets people will be able to put up for, say, as their stake in one of these games. Are they limited to just XCH? Can they use
Yeah,
cat
yeah, you're
coins?
playing just for Chia,
Thank
at
you.
least initially. That's the way it works.
Mhm. Perfect.
Yeah.
And another question from Steve Stepp here, and this is in reference to one of the CNI developers who has a side project.
Mm-hmm.
And this is Rigidity. He's been building out
Mm-hmm.
the Ru language.
Mm-hmm.
The core question is, what do you think about more languages like Ru, but specifically, for the Chia blockchain?
I think it's great to have people do different things for it. Um, just please nobody make a language that's a security disaster. But short of that, yeah, like it's intentionally designed to have compiled languages. You know, Chialisp itself is not really the target. The thing that's real on chain is CLVM, and Chialisp compiles into CLVM, and that's very intentional. So experimentation is good.
Thank you. And completely agreed. Always great to see the development in the community there as well.
Mhm.
And on the timeline side of things, I know there's a lot of people out there who watch the 3-year mainnet anniversary and
Mhm.
they saw your proposed very loose timeline for the new plot format, which of course
Uh-huh.
was this is the soonest it could ever possibly occur type of a
Uh-huh.
conversation.
Uh-huh.
And somebody has asked, is there an updated timeline for that new plot format?
Uh, no. No, there's not. Um, I'm bad at thinking about timelines, and I don't even remember off the top of my head exactly what I said there. I will say that the security level of the new proof of space is looking quite good. That it's not that there's no time space trade-offs, but they're down to a very tiny amount of compression as opposed to, more than half. So that's looking really good. But it hasn't been that long since then, and I don't really have much in the way to report of stuff. The plan is that there will be a an analysis tool that we'll be making available. So we're going to be putting together a proposal, and with that, we're going to make available the thing that we used internally to monkey with the parameters to tune the knobs. We'll be making that available to everyone as well, so that you yourself can try tuning the knobs and see what happens on it.
That is excellent. I know that'll be great to get in the hands of the community and kind of give them that thing to play with. And
Yeah.
for those out there intrigued about more timelines, we will have an announcement after this call about the 2024 roadmap update. We will also have a Q&A about the roadmap update. So feel free to keep your eye open for new announcements after Bram and I get off this call. We will have that roadmap update and be able to answer a lot more of those questions about timelines, what'll be coming out, and all that wonderful stuff. You'll also notice that we are getting near the top of the hour here, so we're going to ask a few more questions. We unfortunately will not be able to make it through all of the questions today, but I will make note of any outstanding questions so that we can capture them in a future Tech Talk with Bram. That being said, I want to get back to the core tech itself, and Orc has questions about BLS opcodes. What
Hmm.
are some minimal uses of BLS opcodes? What is the reason Chia put them in? And what are some other fun things you can do with them?
Well, we put them in just on general principle. Um, like the most basic stuff is non-aggregated signatures. Like, so we're very specifically made sure that those are supported by what we have. If you're doing like routed payments and through a payment network, you really want to have non-aggregated signatures there. So it's nice to have those. Um, we're also doing some looking into having confidential, um, uh, 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 like basically a confidential analog of cats that or sea cats or something like that. That confidential cats that something where you have a thing, well, whose nominal size is 0 on the chain, but you have smart coins that know an encrypted version of their size, but don't actually know what their size is. Or, well, I mean, they know what their size is, but it doesn't get revealed when they get spent. So you get these transactions that validate that things sum up properly the way they're supposed to, but all the individual balances are masked until someone does a real reveal of them. Um, uh, that's that doesn't get you privacy about the trail of what paid into what, but it hides the amounts. So, and it's vastly easier to do than the kind of stuff that like Zcash is doing. So, that's something we're considering for the future is building a standard for doing that. Um, and you could do all manner of zero knowledge stuff with them as well. They really enable that, although that gets a little that's a lot of work. But those are appropriate primitives for that kind of stuff.
Absolutely. Absolutely. Thank you. And I want to finish up. We're coming near that top of the hour. So
Mhm.
for our last question here, I want to finish with a fun one. We're going to go back to movies, but we're going to put you in the seat of the screenwriter.
Okay.
If Chia Network were a character in a sci-fi movie,
Uh-huh.
what role would it play and what futuristic problems would it solve?
Um, the Uh, um, hmm. There's a lot of, mm, well, the obvious thing is the like, here's some money that can't be seized, right? That's kind of the main talking point of these things in movies, which is accurate for like the main thing that Bitcoin does, right? Um, uh, I might be taking the question too seriously in terms of thinking about just not a purely technical level. If you're actually doing screenwriting, how would you like what would you have smart coins do like that would add something to it? Um, the blockchain itself kind of acts as this figure that's enforcing rules. So even if you weren't being very accurate about how the actual thing works, just from a human standpoint, it feels like there's some rules that the characters have to follow in the screenplay, and the blockchain is the thing that is enforcing the rules. That, that acts a little bit omnipotent and uncaring in the process of doing
Absolutely, absolutely. Kind of that security and that protection,
it.
but in a
Hmm.
trustless environment, which,
Yeah.
as we know, when we have to trust central authorities right now, we don't have that ability.
Yes.
Well, Bram, the last thing I want to do, and I know you have it in front of you there, if you don't mind showing a piece of it, is
Oh,
you've been mentioning your new mechanical puzzle to me, and I'm sorry to put you on the spot, but I
okay.
absolutely love it. I think it's an innovation.
All
And if
right.
you don't mind just
Well,
showing
I
a
have,
piece of that.
yeah, so I have a fully assembled one here. So I have, um, well, there's a bit of a mess of me putting together another one on my desk, but here's a fully assembled one right here. And this kind of moves around here, that, like that, and like that. No, no, whoa, like that. So this is a sliding tile puzzle, which doesn't have any particular frame around it. And this is not me just following rules about not taking apart. It is mechanically enforced that it can't just come apart. Um, the way that works is these outer pieces here kind of form a chain and can't get away from the ones next to them. That's the basic idea behind the mechanism here.
Thank you, thank you. And that looks really clean, and that's actually a different version than the last one I think I saw. Did you update how the numbers are put on place there?
Um, well, this one's different colors. I don't
Oh, that
know.
might be it. I'm
Yeah.
colorblind, so that always catches me off guard.
Yeah, I want to, I actually, there's a color, I have a few color projects that I are on my list of stuff to do in my copious free time. I have these like stock rants about colors. How it turns out the there's a bunch of things. Basically, color theory as it's taught in schools is wrong. It's based off of observations from looking at rainbows and from mixing paint, which do some things that are wrong in them. Uh, in particular, there's this impression that that cyan is light blue, which it is not, but English speakers call it light blue, which is very confusing. And then pink is actually a primary color. It's this color here is generally referred to as magenta. It's actually very saturated pink. People don't like, basically, people didn't call it pink because in the 20th century, due to homophobia, no one wanted to admit that they were using the color pink. So everyone euphemizes it as magenta, which isn't totally wrong, but magenta is just a very specific shade of pink. Um, that's um, yeah, and anyway, I have a bunch of rants about the details of that, but one of my projects is to do uh is to do a write a color picker that visualizes things by doing three-dimensional rotations, which is going to be kind of neat. But that's a bunch of work to do, so I haven't done it yet.
Completely understandable. And thank you very much for your time
Hmm.
today, Bram. I appreciate you letting me pick your brain and throw a
Hmm.
few at you from left field and catch you off guard a little bit. So thank you very much for your time and your insights on all of the technology that we discussed, from state channels to blockchain to building mechanical puzzles and even about color theory. Um,
Yeah, yeah. Sorry, I'm a little slow today because I'm still not completely over this cold that I got. So that's
Yeah, no worries at all. No worries at all. And for
Mhm.
those of you who participated with us and asking questions, thank you very much for the insightful questions. We are going to be planning on having a tech talk with Bram every single month. So keep an eye open for the one next month. The other event that we have coming up is next week. We will have a 2024 roadmap update and a Q&A for it as well. So later today, you should see the blog go out as well as the announcement in that regard. Stay tuned. Feel free to jump into our Discord server with any follow-up questions, and I'm making note of any outstanding questions from today that were unanswered. But thank you all for your time. Bram, we'll be in touch, and thank you as always for your insights.
Thank you. Have a good day.
Absolutely. Have a great day, all.